So for this problem, we'll be using ray diagrams and looking at how we use the lens equation now to find location of image and magnification. So we have a camera with the focal length given. That means that we've got that our focal length is 50 millimeters or 0.05 meters. And so it's a positive value, which tells us it's a positive lens. So already we know we have a positive lens. And where it's used to photograph a person standing 3 meters away. So this is like 5 centimeters versus 3 meters. So this is not going to be to scale at all. Here's the focal length. And then here's the object that we're taking a picture of. So if we draw the ray diagram of this, what we have is that we're going to have one ray that comes in straight and then goes out along the focal point, and then another ray, our second ray, it's hardly going to show up here, is going to be like this. It's not even going to be that extreme, and it's going to be like that, okay? And so we're going to get an inverted image because we have a positive lens and we're well outside the focal length. And we'll find that this drawing is not at all to scale because it's hard to scale 3 meters versus 5 centimeters on this scale. So the question is, where should the film be? So the film needs to be where the image location is, right? At the image location. And so we'll go ahead and use 1 over the object distance plus 1 over the image distance is equal to 1 over the focal length. And so this would be 1 over 3 meters plus 1 over the image distance is equal to 1 over 0.050 meters. And you could do the whole thing in millimeters if you prefer. Then you get 1 over the image distance is equal to 1 over 0.05 minus 1 over 3 meters. And when I do that in my calculator, I get 0.0508 meters as the image distance. Okay, so it's really close to the focal length. If the focal length is 0.05, then the image should really be right up against that. Which isn't a surprise because we're so far away from the lens in comparison with the focal length of the lens. Now the magnification is minus the image distance over the object distance. And of course this is what allows us to get images on small pieces of film when we had film cameras, but even in our digital cameras to get the image in a digital format, to get everything in there. And so if we do that, the magnification is minus 0.0508 meters over 3 meters, or I get a magnification of about minus 0.0169. There are no units because the meters cancel out. So it gets minimized quite a lot. It gets to be a much smaller image. And so the point of that is to say if the film is 36 millimeters high, how much of a 1.75 meter tall person can fit in it? In other words, if you're 3 meters away, have you gotten far enough away that you can capture the full length view of a person? And so we can say, well, if an object, if a person is 1.7 meters tall in person, then if we take it times this magnification, or the minimification if we like, how tall will that image be on the screen? And so when I calculate that, I get 0.0297 meters, which is 29.7 millimeters, and so that will fit on a 36 millimeter film. So 100% of the answer to B is that 100% of the person will fit the height of the person, and that makes some sense. If you think of something about 9 or 10 feet away, somebody that far away, usually you can get the whole person in your photograph. If you're closer, you get a smaller view because we change our magnification at that